Okay, so this is question number 6 from your homework yesterday on the AP Classroom website. Looking through the homework, this one was the most heavily missed, and I think it's worth going through and worth showing the answers on. You can check answers when you go back into your assignment, so I would encourage you to do that. The only other misses really came regarding putting a plus or a minus sign on a square root when you're doing separables, and I put a video up yesterday outlining what that looks like. So I would say take a look at all of your answers if you struggled with those. Reference the video I put up from yesterday, but this one is a different issue than that. So we've got a separable, which means we need to get the y's together. So I'm going to do that by dividing both sides by y. And then I'm just going to leave the secant squared of x sitting there on its own and move over the dx. So that would be separating the variables. From this point, then what we need to do is integrate both sides. So we're going to integrate left and right. And on the left, we're going to get the ln absolute value of y equals, and the integral of tangent or of secant squared is tangent of x. And then we need our plus c. So again, from an AP perspective, showing this work is really important. So showing them that you're separating, showing them that you're taking an integral of each side, and then putting the plus c. Then what we need to do is use this initial condition, and they presented it a little differently here. They're saying y is 5 when x is 0, so they're giving us the point 0, 5. Another way that might get presented is f of 0 is 5. Those mean the same thing. And in terms of what we do with it, then we're going to take the 0 and the 5, and we're going to plug it in here. So I'm going to take that 5 and put it in for y, and the absolute value of a positive number is a positive number, but I'll keep the bars there because it's not critical right now. And then we've got tangent of x plus c. Well, tangent of 0 plus c. And tangent of 0 is 0, so we just get the ln of 5 is c. And again, absolute value bars aren't necessary when you have a positive number on the inside. And so then at this stage, we say, okay, let's keep it right here. We're going to do this thing again, except I'm going to take the c out, and I'm going to put the ln of 5 in. And then what we need to do is isolate y. And to do that, I'm going to e both sides. And this is actually where I suspect the problem came. It has, I think, virtually nothing to do with our calculus skills and everything to do with our pre-calc skills in terms of how we're using e. Just based on the fact that the wrong answer that most of you chose just was applying this step incorrectly. So this is kind of the key step for where I saw mistakes getting made based on the answers that you chose. So we're going to e both sides, and I'm actually going to show that because I think that's important. I think particularly for those of you that missed it, but I think for everybody, it's really, really important to be careful and just recognize where the error is coming. This is a really, really solvable error. E is not getting distributed to the powers, and I think that's where the mistake came. So the mistake actually came here with how we handled this right-hand side. E and ln over here, you're left with absolute value of y. And we're going to end up dropping those absolute value bars much along the same line of thinking as we were doing with the plus or minus square root. The y that's going on the inside is positive. And so we're talking about positive y values, and you're using that initial condition to make that decision with the square roots with respect to dropping absolute value bars. So in this case, we're going to get to do that, but it was a multiple choice. You didn't have any option. You just were presented as a y equals. So whether or not you knew to do that, it was just presented that way. And my guess is that that wasn't the problem. The problem came on the right-hand side. E doesn't get distributed to each of those powers. When you have a plus sign in the powers, that is the same, or that is equivalent to E tan of x times E ln of 5. This step, this is where we made mistakes. This is what led many of you to choose the commonly used wrong answer. Actually, more of you picked the common wrong answer based on your pre-calc skill. So really important to diagnose that, know it's there, know that you deserve the points, you know the calculus. You just have to address those small underlying issues. Harder to do in this virtual format than it is in an in-class format to get questions answered, but because I can see what you missed, I think we can, at least on this one, diagnose it. So then you've got a multiplication situation, and again, we talked about the absolute value bars. ELN 5. That's just 5. And the common wrong answer, so this is the right answer. The common wrong answer that you would have been allowed to pick, and many of you picked, was E tan of x plus 5. In other words, you took that plus and dropped it down between the two terms, but that plus is on the powers. And when you have an addition sign in the powers, what that does is it becomes a multiplication sign between the two bases. And hopefully that makes sense. If it doesn't and you watch this video, please follow up with an email and I'll do my best to address it. This is a really little thing, but it's also something that would then derail your answer. So hopefully this helps. Enjoy.